Good morning. I am Mr. Ish. You're looking here at a good video here on trigonometric identities part 2. I've established already a video on part 1. We're looking here at additional identities, but we'll do 2 relevant practice questions related to these identities. Prior to me talking about these identities, let's talk very quickly about the trigonometric ratios. You know, if you have a 30, 60 and a 90 triangle, it generates a 1, a root 3 and a 2 in terms of the sides. These are something you should always remember because you can utilize these for shortcuts and questions, so you don't really need a calculator. The other triangle you should be aware of is a 45, 45 and a 90, which generates sides of 1, 1. These are opposing sides to your angle, 1, 1 and root 2. And this is something you should always remember. The larger side always opposes the larger angle and the smaller side opposes the smaller angle. See, 1 is opposing a 30, 2 is opposing a 90. So that is a good concept to remember. Let's look at these trigonometric identities I have here on the side. These identities are called the sum and difference identities of the trigonometric functions. Here we're looking at sine and cosine. If you know these, you could very well establish the same identities for some of the other functions. Sine x plus y is always equal to sine x cosine y plus sine y cosine x. Not too hard. Something you should ideally commit to memory. You don't have to, but if you did, it would benefit you. Sine x minus y is equal to sine x cosine y minus sine y cosine x. You can see how the pattern is. If there's a plus and a minus here, there's a plus and minus here. Sine and cosine alternate with regards to the angles they're attached to. It's a bit different over here. Cosine x plus y is cosine x cosine y minus sine x sine y. Quite contrary to what you would think. Here you have the both cosines together and the sines together, and the sign is opposite to what you see. Here's a plus, here's a minus. You can imagine what this would be. It would be cosine x cosine y plus sine x sine y. And you can see that minus here, plus here. Cosines and sines. So these are the patterns you need to remember, and we will look at 2 questions over here which will very well utilize some but not all of these, and let's do that. Our first question is this: we have to find without a calculator the value of angle sine of 15 degrees. Always think about those angles you can utilize which relate to those trigonometric ratios I just showed you earlier. 15 can come from a 45 minus 30. These are your trigonometric ratio angles. You know that. Alright, sine 45 minus sine 30. This looks very well like the identity we just looked at, sine x minus y, which you know is sine x cosine y minus sine y cosine x. From this equation form, put your x's and the y's. X here is a 45, y here is a 30. Plug these values in. You're looking at a sine of a 45 multiplied by a cosine of a 30 minus sine of a y, which is a 30, and cosine x, which is a 45. And now think back to those trigonometric ratios. For a 45 degree angle, right triangle, you're looking at 1, 1 root 2. For 30, 60, 90, here's my 30, you're looking at 1, 2 root 3. And this gives you everything you need to plug in right here. So you can do this without a calculator. Sine 45, 1 over root 2. Cosine 30, root 3 over 2. These are multiplying. Minus sine of 30, 1 over 2. I was a little enthusiastic over there. And cosine 45 is a 1 over root 2. Compute all of this. You'll have root 3 over 2 root 2 minus 1 over 2 root 2. Your answer will be root 3 minus 1 over 2 root 2. And this right here, you can present that as your final answer, or you can present a decimal answer, and I will present a decimal answer. My decimal answer yields me a value 0.2588. And now what we can do is check this, 0.2588. All we have to do is do 15 degrees and we'll sign it and we'll get 0.2588, and we know this answer here is good, this answer here is good. Let's look at one more question and then we'll close this video with that. When you're looking at these questions, you always have to remember which quadrant you're also looking at, because the sine, cosine are different. Sine, you know, is always positive in this quadrant, and sine is positive in this. Cosine is positive in this quadrant and in the 4th quadrant. And we're looking here at a cosine of 165, which is in the 2nd quadrant. So here we know our cosine value, our answer better be minus. So you have to pay attention to this specific peculiarity that comes into play. Anyhow, our question is cosine 165 How can we demonstrate 165? There are multiple ways. I'll just show you one way. How about this? We are looking at cosine of 135 plus 30. This right here is a good angle because 135 is a reference angle for 45 degrees in the second quadrant. So you're really looking at 45 degrees here, but in the second quadrant, and that's the route I want to take. So it's not going to be too hard. Now think back to the cosine sum formula, which is cosine x plus y is equal to cosine x cosine y minus, remember minus, sine x sine y. Now if this is x, that's y, plug the values in. Cosine 135, which is the same thing as cosine 45 in the second quadrant, cosine 30 minus sine 135, which is the same thing as sine of 45 in the second quadrant, and sine of 30. 135, as I said, is no different than you looking at a 45 degrees in the second quadrant, and that's what we use, 1 root 2. 30 is no different than a 30, 60, 90, you know that, 1, 2, root 3. Plug the values in. Cosine 135 is the same thing as cosine 45 in the second quadrant, and it's always negative. Cosine 45 in the second quadrant would be what? Minus 1 over root 2. Remember, cosine 45 is 1 over root 2, but in the second quadrant, cosine is negative. Cosine 30 is a root 3 over 2 minus. Sine 135, sine is positive in the second quadrant, but sine of 135 is the same thing as sine of 45 in the second quadrant, which is 1 over root 2, right? You know that. Sine of 30 is 1 over 2. And bring everything together. You have minus root 3 over 2 root 2 minus 1 over 2 root 2. You can say it's minus root 3 minus 1 over 2 root 2, and this can be a good answer, or I will present a decimal answer, then we'll verify it here on the calculator. For my decimal answer, I get this value right here, and I'm going to put it out here, minus 0.9659. I get minus 0.9659. All we have to do is verify this here on the calculator. I hope you can see it, but 165, and then you cosine it, you get minus 0.9659, and we're good. So remember, these sum and difference sine and cosine formulas are very important. Remember also these trigonometric ratios related to the trigonometric triangles. They're very relevant because they eliminate the need for you to get the calculator and work with that. You can present an answer in this way, and it's good. I thank you for watching this video and my other videos. Thank you. Have a great day. Bye.